Hi, in this video, we will be solving word problems of sets involving three circles of Venn diagram. Example number 1, show in Venn diagram for set U, A, B, and C, where the universal set is equal to 1, 2, 3, 4, 5, 6, 7, and 8, and A is the set of 2, 4, 6, 7, and B is the set of 3, 5, 6, 7, and C is the set of 1, 4, 5, and 7. We already have here our Venn diagram with three overlapping circles labeled as A, B, and C. So for us to begin with, we will identify the intersection of these three sets A, B, and C, and it will be placed here at the innermost area. Investigating our given, I can see 7 in set A that is also present in set B and set C. Therefore, the intersection of these three sets is 7. The next thing to do is we will be working in pairs, or we will partner these sets. So the first sets of pair that we are going to work with is set A and set B. But let us remove this 7 because it is already present in our Venn diagram. Investigating between A and B, we can see that 6 is common to set A and B, and it will be placed in this area. It means it is present in A and B but not in C. Okay, the next set of pairs that we will be working on is set A and set C. Let us remove the elements that we already placed in our Venn diagram. So for set A, I will remove 6 and 7. For set C, I will remove 7. Now, looking at set A and set B, the common element is 4. We have 4 in set A and we also have 4 in set C. It will be placed in this area. Common to set A and set C but not in B. And that is 4. So lastly, the pair of set B and set C will be compared. So we will be removing the elements that are already placed in our Venn diagram. For set B, we will remove 6 and 7. For set C, we will remove 4 and 7. And investigating it, the common element between B and C is 5. Now, at this time, we will look into the distinct elements of every set. Let us begin with set A. Looking at set A, 4, 6, and 7 are already placed in our Venn diagram. Therefore, the distinct elements of set A is 2. In set B, we can already see 5, 6, and 7 inside our Venn diagram. Therefore, the distinct elements of set B is 3. For set C, 4, 5, and 7 are already placed in the Venn diagram. Therefore, the distinct element of set C is 1. Now, let us investigate our universal set if all elements are already placed in the Venn diagram. Now, I can see 1, 2, 3, 4, 5, 6, 7 in the Venn diagram except 8. So, this 8 will be placed outside the 3 overlapping circles. And that is the process on how to show Venn diagram with these givens for set U, A, B, and C. Example number 2, a group of Filipino tourists went on summer vacation this year. Of this number, 23 went to Boracay, 20 went to Cebu, 16 went to Palawan, 9 went to Boracay and Cebu, 7 went to Cebu and Palawan, 5 went to Boracay and Palawan, and 3 went to all of these 3 places. So we have here our universal set with 3 overlapping circles, B representing Boracay, C representing Cebu, and P representing Palawan. In this example, our universal set is 45. And then we will be working backward, and then we will start at the center of the 3 overlapping circles it is in this area where we can see the intersection of our three sets. So on our given, it says here that 3 went to all of these three places, meaning these three tourists were able to visit Cebu, Boracay, and Palawan. So we will place 3 at the center. Next thing is we have here 5 went to Boracay and Palawan. So Boracay and Palawan is this intersection. It says here that we have 5 who traveled Boracay and Palawan, but we have already taken 3 at the center for the intersection of our 3 sets. So we will subtract this 1. So 5 minus 3, we only have 2 who visited Boracay and Palawan, but not Cebu. Next is we have here 7 went to Cebu and Palawan. So Cebu and Palawan is this intersection. But we have already taken 3, so this will be subtracted to 7. So we only have 4 that visits Palawan and Cebu, but not Boracay. Next is we have here 9 went to Boracay and Cebu. So this is the intersection for Boracay and Cebu. So we have 9, and then we are going to subtract this intersection. That is why we only have 6 tourists that visited Boracay and Cebu, but not Palawan. The next thing is to identify the specific elements of every set. We will start with Palawan. So it says here there are 16 visitors of Palawan. So this is our area of concern if we are going to talk about Palawan. So we have here 16, and then we are going to subtract these elements under the area of Palawan. So we have 2 plus 3 plus 7. That will give us 12, and it will be deducted to 16. So it will give us 4 distinct visitors of Palawan. Next is we have here Cebu. So there are 20 visitors of Cebu. So this is our area of concern for Cebu. And we are going to add this 6 plus 3 plus 7, and that is 16. 20 minus 16. So we have 4 distinct visitors of Cebu. The next is we have here Boracay. So there are 23 visitors of Boracay, and this is the area of concern for Boracay. So we have here 23, and then we are going to subtract the total of 6 plus 3 plus 2, and that is 11. 23 minus 11, we have 12. Therefore, we have 12 distinct visitors of Boracay. The next thing that we are going to do is we are going to determine the union of all sets, the union of B, C, and P. And we can do that one if we are going to add all the values that we can see inside our circle. So we have here the union of B, C, and P. So we are going to add all the values. We have 12 plus 6 plus 4 plus 2 plus 3 plus 7 plus 4. And we have the value of 38. And then we are going to determine the complement of the union for us to know how many elements or how many tourists did not visit any of these tourist sites. So we have here the universal set, which is 45, minus the union, which is 38, and that will give us 7. And the 7 will be placed here. So these are the number of tourists who did not visit any of the tourist sites that were mentioned. So we are now ready to answer some questions. Number 1, how many of them visited Boracay only? So this is the area where we can see the number of tourists who visited Boracay only. So there are 12. Next, how many visited Cebu and Palawan but not Boracay? So visited Cebu and Palawan. So visited Cebu and Palawan but not Boracay. So this is the area that we are looking for, and that is 7. Next, third, how many of them visited Palawan but not Cebu? So visited Palawan but not Cebu. So this is the area that we are looking for. So we have here 2 and 4. So we have to add these figures, 2 plus 4, and that will give us 6. Okay, next, letter D. How many did not go to any of these 3 places? So we have here 7. So these 7 tourists probably visited other tourist site aside from what we are looking for Boracay, Cebu, and Palawan. So, okay, letter E. How many tourists did not visit Cebu? So we are going to exclude this Cebu, and the rest is our concern. So if we are going to shade this Venn diagram, so all the shaded area will be included except Cebu. And on our given, so there are 20 who visited Cebu, and our universal set is 45. We simply have to subtract this 45 minus 20, and that will give us 25 tourists who did not visit Cebu. Letter F. Okay, letter F, how many tourists visited at least one of the tourist sites? So again, we have here our keyword, at least one. It means union. So we have to add all the figures that we can see inside our circles, and that is 38. Example number 3. 50 individuals were asked about their color preferences among red, blue, and green. 36 like green, 20 like blue, 18 like red, 16 like green and red, 13 like green and blue, 7 like blue and red, and 5 like all colors. So let us fill in this Venn diagram. So as what we've practiced, we are going to begin with the center or the intersection of these 3 sets. So we have here 5 like all colors. So this is the intersection of the 3 sets. So 5 will be placed at the center, and then we will work upward. So 7 like blue and red. So 7, but we have already taken 5, so that is why we only have 2 who likes blue and red but not green. Next, we have here 13 like green and blue. So this is the area, green and blue. But we have already taken 5. That is why we only have 8 that likes blue and green but not red. Next is we have here 16 like green and red. And then we just have to subtract this 5 to 16. That is why we only have here 11. The next thing that we're going to do is to determine the distinct elements of every set. So we are going to begin with red. So it says here that 18 like red. But take a look at this. If we are going to add 2 plus 5, that will give us 7. 7 plus 11, that will give us 18. And that is the total number of individuals who like red. So we are not going to write anything in this area because it will go over to our data. So we will proceed to the next. So the next one, we have here 20 like blue. So this 20 will be subtracted by these values 8, 5, and 2. So if we are going to add all of these 3, we'll have 15. Then 20 minus 15, we only have 5. And lastly, we have 36 who likes green. And if we are going to add these values, 8 plus 5 and 11, and the total will be subtracted to 36, it will have a remaining value of 12. Next is we are going to get the union of these elements. So if we are going to add all of these values, we have 5 plus 2 plus 8 plus 5 plus 12 plus 11. It will have a sum of 43. So the union of all sets is 43. So take note, this 43 is over to our universal set. Our universal set is 50, and that would tell us there are 7 individuals who did not like any of these 3 colors, blue, red, and green. And that is the complement of the union of B, red, and green, and that is 7. Let us answer some questions related to problem number 3. Number 1, how many likes blue and red? So we have here a keyword that we need to be you need to be cautious about. So we have here the word or. If we will encounter this or, it means union. So we are going to add all the values that we can see under blue and red. So under blue and red is this one, blue and red. It means that we need to add this 5 plus 2 plus 8 plus 5 and then plus 11, and that will give us a total of 31. Question number 2. How many likes red and green? So we have another keyword that we need to be cautious about. So if we have here and, it means intersection between red and green. And that area, red and green, is this area in our Venn diagram. So we have to add these two figures, 5 plus 11. So the total number of individual who likes red and green is 16. We have our third question. How many likes blue and red but not green? So they like blue and red. Blue and red but not green. So the answer here is only 2 individual who likes blue and red but not green. Fourth question. How many likes red only? So our answer in this item is 0. Nobody likes red only. Letter E. How many likes red? This one, this is the cardinality of red that we are asked. So how many all in all likes red? And if we are going to look at our given, there are 18 individuals who likes red. So our answer here is 18. Next is letter F. How many likes blue but not green? So this is the area we are looking for. This is the area of blue, and then we have to remove the area that has green. So this will be excluded. So looking at the values, we have 5 plus 2. So the answer is 7. Next, how many likes only one color? So we are going to determine all the sets which has distinct elements. So blue has 5 distinct elements, and then green has 12 distinct elements. For red, we have 0. So we will only add 5 plus 12, and that will give us 17. And that would be all for today. Thank you so much. I hope you learned something today. Bye-bye.